Welcome to a SIM code. Welcome back to the channel, friends. If you're loving the content, be sure to like and subscribe. Graphing and visualizing network topology involves creating a visual representation of the structure and connections between devices in a network. Using tools like Python's networks library, one can model networks as graphs where nodes represent devices, routers, switches, computers, and edges represent the connections between them. Visualization libraries like Matplotlib can then be used to draw and display these networks, providing insights into how devices are interconnected. Network topologies can vary in structure, such as star, bus, or mesh, and visualizing them helps in understanding traffic flow, identifying points of failure, and improving network design. For instance, by creating a graph with nodes for each device and edges for their connections, and positioning the nodes with algorithms like spring_layout, one can generate clear diagrams that represent complex networks, making it easier to manage, troubleshoot, and optimize the infrastructure. Importing necessary libraries. Networks is a Python library used for the creation, manipulation, and analysis of the structure of networks. Matplotlib.pyplot is a plotting library that helps us visualize graphs. Create an empty graph. G equals nx, graph, creates a graph object called G. This object will store our nodes, representing devices in the network, and edges, connections between devices. The graph, class from networks, represents an undirected graph. An undirected graph means the edges don't have direction. Adding nodes to the graph. A node represents an individual device in the network. Here we are adding 5 devices. Router, switch, device A, device B, and device C. Each add_node method call adds a node, device, to the graph G. Adding a router node to the graph. Adding a switch node to the graph. Adding device a node. Adding device B node. Adding device C node. Adding edges between the nodes. An edge represents a connection between 2 devices, nodes. The add_edge method connects 2 nodes with an edge, creating a link between them. The nodes are passed as arguments to add_edge, and it creates a bidirectional connection between them. Router is connected to switch. Switch is connected to device A. Switch is connected to device B. Switch is connected to device C. Define a layout for visualizing the network graph. nx.spring_layout (G) is a function that positions the nodes in a visually appealing way. It uses a force-directed algorithm where nodes repel each other and edges act as attractive forces. This layout ensures the graph looks organized and is easy to understand. Visualizing the graph using Matplotlib. plt.figure, fig size sadface 8, 6, creates a figure with the specified size, width of 8 inches and height of 6 inches. This sets the size of the visualized network image. nx.draw is a function from networks used to draw the graph with the specified layout and style. POS equals layout specifies the position of the nodes from the Spring layout. With_labels equals true ensures that node labels, device names like router, switch, etc., are shown. Node_size equals 3000 specifies the size of the nodes. Node_color equals sky blue colors the nodes with a light blue shade. Font_size equals 12 sets the size of the node labels. Font_weight equals bold makes the font of the labels bold. Edge_color equals gray colors the edges, connections between nodes, with a gray shade. plt.title, simple network topology, adds a title to the graph. This is helpful for giving context to the visualization, like labeling it as a simple network topology. plt.show displays the graph to the screen. This command renders the visualized network graph that we just created. Now run our code. If you liked this video, don't forget to like and subscribe for more.